Good morning. It's Mr. Crich. And today we are into learning lesson 4 of the online learning, Physics 11, and it's about Newton's second law, which of course is F equals ma, or as we'll find out later, F net equals ma. This is the formula for Newton's second law. Force equals mass times acceleration. And force is in the metric system, certainly in physics, is in newtons, and mass is in kilograms, and acceleration is in meters per second squared, as it was when we were doing kinematics. This formula, as it's written right here, doesn't really tell the whole story. It really should be net force is equal to mass times acceleration. And net force is really a tug of war of forces. There will be a winning force and a losing force, just like there is in a tug of war. But in the case of Newton's second law, something will accelerate. So one force will be greater than the other, and that will be the winning force. So we often write this down, net force, as winning force. And it's minus the losing force in the tug of war is equal to mass times acceleration. In the case of the pushing van video that's on my YouTube, the winning force is two students pushing with 80 newtons each. So it would be like 160 newtons would be the winning force. The losing force is the friction force. Could be with the ground, could be with the air. But the friction force in this example is 50 newtons. And if the mass of the van was 1,000 kilograms, then it would be easy enough to calculate the acceleration of the van. You would just go 160 minus 50, which is 110, and equals 1,000 times the acceleration. Divide each side by 1,000, so the acceleration is 110 over 1,000, which happens to equal 0.11 meters per second squared. In the Hewitt-Druitt problem, he has a skydiver called Susie who is jumping out of a plane, and in her example of Newton's second law, you would approach the solution the same way. You go F net is equal to mass times acceleration, so the net force on Susie is equal to Susie's mass times her acceleration. So F net would be the winning force, minus any losing force, which is usually the force of friction, is equal to mass times acceleration. The winning force in this case is her force of gravity. He calls it mg. It's the same thing as her weight. So the winning force here is her weight, or the force of gravity. The losing force is the force of friction. He calls it air resistance, or R, so force of friction. And that equals m times a. Well, if Susie has a mass of 70 kilograms, using the terminology that Hewitt uses in his problem, the winning force is mg, the losing force is r, which is the air resistance or air friction. That equals her mass times acceleration. So m would be, if it's 70 kilograms for her, 70 times 9.8 minus air resistance. And if the air resistance happened to be, for instance, 300 newtons, that would equal her mass 70 times the acceleration you're trying to find. 70 times 9.8 is 686. And minus the friction at that point in her fall is 300, is equal to 70 times A.